Now, instead of asking when should I model, a better question is probably in what level of detail should I model? Proponents of modeling have a popular theory that says that if the same developer were to approach a new task in two different ways, one with 90% of the total effort was planning and 10% was coding, versus an approach where all 100% or close to it was spent coding, the first option would always be faster and cheaper to develop. This is because taking the second approach, which is completely reactionary, doesn't allow for any forethought to problems that can arise only after most of the task has been completed. This leads to rewrites and costly re-engineering, or even worse, an application that does not contain complete functionality desired by the user. If you get any type of request, it's important to somehow write out your plan on a piece of paper, or if existing documentation exists, being ready to edit that document to include any changes that you make. I've given some scenarios here that can be used as a guide as we come up with more formal guidelines and requirements for application documentation. However, it should be noted, when we're talking about modeling in UML, I'm not limiting documentation to UML. Now, UML 2.0 consists of 13 diagram types, up from 9 in UML 1.0. Since the tenet and rationale behind this discussion is more about documentation to help understand and communicate, we go beyond the UML standard and include other diagrams such as database diagrams. In the reference section, I have included some links regarding UML documents for both UML 1 and 2. Again, not to be concerned right now about how to go about learning all these types of diagrams, but to know at least that they currently exist and they're available to use. Now guys, one thing I can't stress enough is the importance of embracing the concept of planning and modeling before jumping into code. If in the current environment there is not a strong culture of this type of behavior, it's critical that someone in your group enforces some sort of best practice when it comes to modeling. Once there is a baseline established in the culture, it becomes easier for others to jump on board. Just as if you were to work at a technology firm where the skill level is low versus one where it's very high, you'd expect that by working at the high-skilled firm that you'd learn much more. The same is true in the area of planning and modeling. If a culture exists where this occurs, it will become habitual and common practice. And more importantly, once we get everybody on board, one very likely result is that by default, our applications will become more modular, which means changing, updating, or even migrating to a web service environment becomes much easier. Okay, to sum up, let's review some of the important concepts that we're trying to convey here. Number 1. Modeling leads to object-oriented development, important documentation. Although we've discussed at length why it's important to model an application, we need to understand that the result of a well-documented application is the documentation that comes with this by default. This documentation tells a story of how the application is built and what it does, both key components in a project's maintainability and sustainability. I can't tell you how frustrating it is to see people working on new software because nobody really can understand what the current software does, so they have to replace it. In regards to object-oriented development, by forcing modular design, modeling helps enforce the concepts that foster object-oriented code, which in turn helps soften the blow of changing or new requests. Number 2, it's easy to treat the planning and modeling portion of a project as a project in itself. Now you got to resist that temptation and learn how to use modeling so that it's habitual and just another part of the overall project life cycle. Ensure that you can quickly update your models as part of an overall continuous integration plan and as an integrated piece of the agile programming model. Number 3, modeling does not delay a project. This is a concept that you should embrace right away. Remember, the goal of planning and modeling is to get a high quality deliverable as fast as possible. It shares that goal with the agile programming model. The concept here says that if you try to jump into code right after the first BRD is complete, instead of going through and planning the architecture and modeling the flow of the application, it'll take longer for you to get to the actual finish line. Number 4, modeling isn't hard to learn, but it's hard to begin. Just as in most new endeavors, the toughest part of learning a new skill for your toolbox is simply to start using it. I suggest that every time you get a new request, start doing some whiteboarding or a plain old pencil and paper and start charting the request modularly so you understand it. Once that's done, look for a more formal document that you can use and present to help communicate the current state of the request. Now, I promise you in future presentations they'll be a lot more flashy, a lot more fun, and this one probably wasn't much fun to listen to. Because you know what, modeling really isn't that fun. We all like to jump into code and see things start happening right away, but this is an important piece to your developer toolbox, and it's really important that you learn this.